In this video, we're going to be taking a look at a person standing on a beam that's connected to a cable, and we're going to be analyzing the torque exerted on the beam in order to figure out the tension in the cable. So first of all, we have to recognize all the areas that are applying torque on the beam. So we have this person who is 60 kilograms, and because they have a force of gravity pulling them down, that is going to have a particular force along with this lever arm of 2 meters that is going to be exerted on the beam. Now, as we're taking a look at all the torque exerted on this beam, we're going to consider this to be the pivot point right over here, so that our lever arm for the person is going to be 2 meters. Now, since the beam itself has weight, it is 40 kilograms, we're going to find the center of mass right in this middle over here, and that also has a force of gravity as well. We'll call it FGB for force of gravity of the beam, and then maybe we'll call this FGP for force of gravity of the person. And the force of gravity of the beam is going to be found at the center of mass. So the total length of the beam is 3 meters, or excuse me, 6 meters. So the center is going to be at 3 meters. And then lastly, we have a force of tension that is being applied in this direction, which is what we're looking for. And for that one, what we're going to do is we're going to use the perpendicular distance from the force to the pivot point. So we'll call that distance D, and that's unknown. So what we're going to do is we're going to have to use a little bit of trig. So we have a 40-degree angle right over here, and we have the hypotenuse of our triangle. So this, because it's a perpendicular line, would be 90 degrees, and the hypotenuse of the triangle is the beam itself, which is 6 meters. So what we can do is we can go ahead and use the sine of 40 degrees, and that would equal the opposite end, which is the distance D that we're looking for, and then over the hypotenuse, which is the 6 meters, the distance of the beam. Now, if we go ahead and do a quick little cross multiply, we can send the 6 over to the other side, and 6 times the sine of 40 is going to give us about 3.86 meters. Okay, so now we have everything we need. We identified all of our forces, and we identified the distance to be used as the lever arm. Now all we have to do is set up our torque formula. So our torque formula is going to look something like this. The net torque, the sum of all the torque provided on the beam, is equal to these two that are twisting it counterclockwise. So we'll say the torque of the beam plus the torque of the person, and then we would subtract the torque of the cable, and that's going to equal 0 Newton meters because the system is at rest and there is no angular acceleration. So let's go ahead and plug in all of our forces, lever arms, and let's solve for that unknown T. All right, so I went ahead and plugged in all our number values. So as I said before, we have the two torques from the beam and the person acting in the what I call the positive direction. And then I subtracted the torque of the cable that is twisting it clockwise in the negative direction, equaling 0. So we did mg, the mass times 9.8, to get the FG for the beam. The 3 meters is the distance of where it is located for the center of mass. And then we did the mg, the 60 times 9.8 for the person, located at 2 meters from the pivot point. And then we subtracted the T, force of tension, times that lever arm that we found in earlier in orange over here. And if you take the product of these two and then sum them up, we get 2,352 Newton meters. And then I added the T times 3.86 to the other side, which set these two equal to one another. Divided both sides by 3.86, which left us with a tension of 609.33 newtons. So to sum things up, if you take a look at a situation like this, you identify all the places that are exerting a torque on the beam, and then you place them all into a formula before then placing your numbers in to solve for the forces and the lever arms, and then you can go ahead and solve for your unknown tension after that. So I hope that was helpful to you. Thank you for watching and listening.